Hello students, welcome back. Now let's go to the next topic, that's quadratic equations. What's a quadratic equation? An equation that looks like this. We have square term, ax squared plus bx plus c equal to 0, where a is non-zero. That kind of thing is called quadratic equation. Of course, the right-hand side does not have to be 0. If there's something else, then of course we can move those to the left-hand side and make this into 0. But this one over here should not be 0. If a is 0, then you have linear equation, just first order. Now, how do I solve quadratic equation? Basically, there are three methods. And we're going to talk about the factorization method only in this video. And the other method, we're going to do in something different. We're going to do those in separate videos. Anyway, this is typical solution for monic trinomial equation. Monic, what do you mean by monic? The quadratic coefficient is 1. You have just x squared, not 2x squared, not 5x squared, not negative 6x squared, but just x squared. In that case, it is possible to factor like this. Factor of the last term, constant term, may add up to the middle coefficient. In that case, you can factor. And the right-hand side is 0. You see, right-hand side is 0, which means first factor is equal to 0, or the second factor is equal to 0. There's no way you're going to get 0 by multiplying two non-zero numbers. You see? You have blue or red is equal to 0, which means either blue is 0 or red is 0. From blue, I'm getting x equals to negative a. From red, I'm getting x equals to negative b. Or you may have negative sign over here. In that case, this a times b is, as a matter of fact, negative times negative b. So in that case, you can factor like this. X minus a times x minus b is equal to 0. So either blue factor is 0 or the red factor is equal to 0. From the blue factor, you get x equals a. From the red factor, you get x equals to b. And the typical deal is you have a sign change. X minus a, then that means x equals to a. X plus a there, that means x equals to negative a. Am I making sense? As a matter of fact, maybe not, so let's just go ahead with some actual problem set. Okay, here we go. X squared minus 6x plus 8 is equal to 0. And let's find out factors of 8 that add up to negative 6. What are those? 2 times 4? 2 plus 4 is 6. So am I getting x plus 2, x plus... Is that what I'm getting? So x first factor is equal to 0. Second factor is equal to 0. Therefore, is that what I'm getting? Pretty much like this? No, not really. Not really. It's the latter case. You see, this is negative. So one way to get 8 is 2 times 4, but another way to get 8 is negative 2 times negative 4. Both should be negative so that they add up to negative 6. So the first factor is x minus 4 is equal to 0. Second factor, x minus 2 is equal to 0. So x is positive 4 or x is positive 2. They are solutions. That's quadratic equation. I don't need this anymore. Now, I believe everybody went through this already in elementary algebra. Even if you haven't, no, I don't think I have encountered anybody who hasn't done this in elementary algebra. I taught intermediate algebra many times, but this one pretty much everybody remembered. when the first coefficient is 1, it's easy. Even if you forgot about those, you can very easily adjust to it. Factors of 8 that add up to -6. You see, this is positive, so we have two same sign. -2, -4. Let's go to the next problem. Factors of -18 that add up to -7. That's what you're looking for. Now we have two opposite sign here. This is -18. So let's see. What are those numbers? 2 times 9? 2 times 9 is 18. Which one is positive and which is negative? We need -7. So we need y minus 9, y plus 2. You see, -9 plus 2 add up to -7. So what do we have? Y minus 9 is equal to 0. Y plus 2 is equal to 0. Therefore, y equals to 9 or y equals to 2, and those are the solutions. It's easy. See? Now, here is a problem that is a little bit worthy. A little bit worthy in a sense that we're going back to this. Denominator, parentheses, and like terms. This basic strategy is not just for linear equation, but for all equations actually. We don't have denominator this time, but we do have parentheses. So let's take care of the parentheses first, and then let's change it into standard form and do something about it. Z squared plus 2z minus 18 equals 2. Well, we have to break up this parenthesis. 6z minus 18. Did I do this right? Okay. And then flip everything to the left-hand side. Z squared plus 2z, and then I have to flip it over. Minus 6z minus 18 plus 18 is equal to 0, because I have to flip these to the other side to keep the right-hand side equal to 0. And in order to do that, I have to change the sign. This is negative and the positive. Okay, what do you get after taking the like terms together? Z squared minus 4z equals to 0. Is that right? Is that right? 18 cancel out. Okay, all right. How do you factor this? These were trinomials, so you could look at the factor of the third term, and then they should add up the middle coefficient, either positive or negative, or two different signs or something. But we have only two terms. It's a binomial. How do we handle that? In that case, there are a number of ways to handle it. One way is to look at the GCF, greatest common factor. This one is z squared. It's on z. Z is common, so take it out. That's what we're getting. So what do we have? Oops. Wrong key. Blue times red is equal to 0. So we have to have blue equal to 0, red equals to 0. So t is 0, or c minus 4 is 0. One of them has to be 0 because I'm not getting non-zero numbers by multiplying. I'm not getting 0 by multiplying non-zero numbers. Right-hand side is 0, that's why this thing is working. If right-hand side is not 0, then it's a moot. You have to move everything and keep the right-hand side equal to 0. So what do you have? Z is equal to 0, Z is equal to 4. Those are the solution. That came from the blue factor, and this one came from the red factor. Not too bad, isn't it? Yeah, we have enough time for one more problem. I assigned a lot of problems in my math lab, so exhausting these problems here Does not bother me. Okay, let's work it out. 3t squared plus 3 equals to 2 minus, oh, how do we break this one up? Negative 2 times 3t, what is it? 6t. And then distribute. Does it look okay? No, not okay. I made rather typical mistake. Negative 2 distributed 3, okay. Negative 2 distributed to positive 1, we need another sign change there. Okay, alright. 3t squared plus 3, and then let's see, this 2 and negative 2 cancel out, no problem there, but negative 6t looks like I need it over there. Is this monic equation? Yes, indeed. Everything is divisible by 3, so divide everything by 3. So t squared plus 2t plus 1 is equal to 0. Alright. And then let's factor this. Factors of 1, that's adding up to 2. That's really easy. Factors of 1, 1 times 1, that's the only possibility. I don't have anything else there. So t plus 1 times another t plus 1 equal to 0, or equivalently t plus 1 total quantity squared is equal to 0. In any case, I'm going to get t equals negative 1. By the way, this kind of form is called complete square formula. It appears a lot, so it's really worth remembering. This one. Oops. This formula. Complete square formula. It's very, very useful. Now, if this is minus, then only this one changes sign. Square part stay positive. When this is plus, plus, minus, minus. Complete square formula is extremely useful. It applies over here. But if you use usual factoring method, it works as well. Okay, so much for monic quadratic equations, and we're going to discuss non-monic quadratic equation in a separate video, and that is going to be really worthy of college algebra. This one, nay.